Okay, so how about this? You can do it on your own, or you can just follow along with me. It's up to you. How's that? Freedom. Okay, name the type of graph, the graph that connects midpoints, and the frequency, that would be a frequency polygon. That's the line graph where you connect the midpoints, right? Name the type of graph that illustrates a frequency with bars. That's a histogram. You got to make sure that if I ask you for a histogram, that you draw a histogram, okay? Um, that's why I kind of just review it here real quick. Name the three measures of central tendency. You have your mean, median, mode. What shape does a normally distributed data produce? A bell curve. What percent of normally distributed data falls between -2 standard deviation and +1? Right, so you always remember, right? There's your mean. So -2 would be right here, and +1 would be right here. So we have 34, 34, and this is 13.5. Like if it's specifically, right, giving you the exact standard deviation, then you just use your knowledge here. We have 81.5. If you use your calculator on a question like this, remember you can also replace this with z-score. The z-score of -2 tells you that, right, you're 2 standard deviations to the left, and a z-score of 1, right, tells you that you're 1 standard deviation to the right of the mean. So you could technically use your calculator in that instance, right, normal CDF, right, -2, 1, 0, 1, and find the same. But when it's exactly like that, I would prefer you just using your knowledge of the standard normal distribution. If the majority of marks fall between 54 and 88, calculate the mean mark for that class. So the majority means is referring to 99.7%, which should also tell you that it's plus or minus 3 standard deviations from the mean that we're talking about. So just an observation. So to get the mean, you take the high and the low, divide that by 2, and we get 71%. So make sure you include units. Pretty much everything on the test will have units associated with it, right? So grams, hours, minutes, you name it. Calculate the standard deviation of the previous question. Standard deviation is high minus the low. How many gaps are there between these two? 6, right? Because there are 3 and 3 to either side of the mean. So we have 6, and that was all determined by this. The majority told us that it's 99.7, which is plus or minus 3 standard deviations. So that's 6 gaps in between. We have 5.67%. I'm going to double check that. Yeah, okay, we're good. Let's see. Let's keep going. State the formula for calculating standard deviation by hand. This one, you don't need to memorize this formula. You just put it on your study sheet. And this is what it is. Standard deviation is the square root of the sum of every single value minus the average. All of that divided by n. Don't stress about that too much. Actually, don't stress about it at all. The only thing I'm going to say here is that there's going to be a bonus question where you have to show me to calculate this by hand. Like, how would you calculate the standard deviation by hand? I will give you a bunch of numbers. I will look up that video. I just didn't cover it with you because COVID. That's basically it. And it's to do this for a big data set. It's crazy much work. It's too much work. You would never do that in real life. But if it's a smaller set, you should be able to do it. So if you want to score those extra marks on the test, then watch for that video that I'm going to post for it. Okay. Other than that, don't worry about it. Okay. So using the table above, answer questions 9 to 13. We're supposed to find the mean, median, standard deviation, and so forth. What happens when you have an interval like that? You got to find the midpoint, right? So you got to add them up and divide it by 2, so you get 47. You get 51, 55. So you're going up by 4, right? You should see that pattern. 59, 63, 67, and then 71 here. So these are my midpoints. That's what's going into L1, and the frequency goes in L2. So we don't know what it is. If it's people, right? Trees, we don't know in this case. Not enough information. So let's go ahead and enter that. Some of you probably beat me to it already. And 4, 8, 13, 15, 22, 18, 4. I'm just going to double check real quick. I don't like to do this whole thing and then be wrong. It's just too much work that you put into it, right? So 71, 67, 63, 59. It takes seconds to check, and it saves you a lot of grief, okay? And then we go and figure everything out. Oh, I should say this, never sort, okay? Like when you do a table like this, don't sort, because you're gonna, if you only sort one, like these match, they have to be paired up, okay? So when you're having 2 columns, don't sort, okay? Stat calc, 1 variable. There we go. So I have 60.38, and we are in inches for my mean there, right? The median, median is 63 inches. Let's do this, okay? Before I do any of this, I'd like you to show this work here. There we go. And then you can answer like those questions because it's all based on that anyways. And then the standard deviation is 6.19. Okay. The number of the sample is 84. Oh, people. All of a sudden we know that it's people. Sorry. So assuming normal distribution, state the range for 95% of the heights. What is going on there? This is what's going on. The range is the low, right? What's the lowest, what's the highest? So this is your mean. Let's go back to 1, 2, because 95% should tell you that it's within 2 standard deviations. So this is, right, 2 standard deviations here, 2 standard deviations there. Our average is 60.38, right? And so we subtract a standard deviation from both sides. This is probably a bit more work. what you could do is simply do this, right? The low is the average minus 2 standard deviations, which is 619. Okay, and that gives you, I think, 48 exactly. I'm just going to double check. Minus 2 times 6.19. That's exactly 48 inches on the low end. So this will be 48 inches here. I basically just went times 2 standard deviations to get me to here. And then the high, right, on this end would be 60.38 plus 2 times 6.19, which gets me to 72.6. No, 72.76, my bad, inches. So the range would be dot dot, right? 48 inches to 72.76 inches. Okay. So 95% of people would be expected to be within these two heights, right? That's basically, so how did I come up with that? It all came back to the 95. You should have recognized that. Oh, okay. If I had put 68 down, it's only from here to here, right? If it's 99.7, you would have had to go back 3 and then over 3, right? So keep that in mind. So this is answering 13 basically, right? State the formula for calculating the z-score. That one you should know. You take your actual data point you're interested in finding the z-score for. You subtract the mean and you divide it by the standard deviation. Make sure this is on your study sheet. Okay, backside. Now it's going to get a bit more interesting. We're going to use our calculators a bit more. Are you making fun of being interesting? What's that? Oh, yeah. Most of these types are one-sided, right? So, but this one has two. Okay, what z-score would have only 23% of data greater than it? So let's do this at the top here because we're going to use it. Okay. Let's do this here. Z-score is 0, 1, 2, 3. And then you have -1, -2, -3. Okay. And so this is the z-scores. Okay. What z-score would only have 23% of data greater than it? Okay. So you would like, again, I have to emphasize, the middle is would you would have 50 less than it, 50 greater than it. So if you have 23% greater than it, you're further up here. So I'm just going to make a mini one here. So that would be 23% here, which would put us on the other end. Oops. This would be 77%. And this is what inverse norm wants, right? So we're looking for that z-score that would put us in this place, okay? So what do we use for that in this case? If you're given the percentage, you use inverse norm and you put down what's to the left of it. They gave you the percentage to the right. We subtract that from 100. So as a decimal, that is very important. As a decimal, 0.77, comma, you're interested in a z-score. So we know that the mean is 0 and the standard deviation is 1. Okay. You plug that in, you get a z-score of 0.74. And remember, z-scores do not have units. So where's 0.74? Positive would be right about there. So if you are there, right, then you would have 23% of data being above you. Okay. What percent of data lies between -1 and 1? That would be 68%, easy. What percent of data lies between z-scores of -2 and 1.25? They're asking for percent, and they're not giving us exact z-scores, right? So we need to use our calculator. Normal CDF, I want to see this. -2, 1.25, 0, and 1. I can do it on my calculator, but I think I'm just gonna, sorry, I always go times 100, right? That's how I showed you. And we will go 87.16%. What percent of data is less than a z-score of 1.76? Normal CDF. We want, basically what it's saying, another way of putting it is 176 or lower. So we're going to make the lower really low, right? And then so this is like almost, we almost want to say go to -infinity, almost. That's what we're saying there. And up to 176, 0, 1 is our mean and standard deviation, and we get 96.08%. So this is just dealing with z-scores. That's it. So everything is 0, 1 at the end, right? Normal CDF needs 4 entries. Inverse norm needs 3 entries separated by a comma. Right, Susie received a mark of 87%, that is, on her exam, while the class average was 76%, with a standard deviation of 5.6. Answer questions 19 to 24 based on this information. Calculate Susie's z-score. We have everything we need. So the z-score, you take her actual mark, you subtract the average, and you divide it by the standard deviation. Because all units are the same, we don't need to convert it to decimals. If you wanted to, you would get the exact same answer. Okay? And so we go ahead and do that, and we get a z-score of 1.96, which tells you that Susie did pretty good, right? Almost 2 standard deviations to the right. So the higher and the plus you are, the better you have performed. What percent of the class did better than Susie? Okay. A couple of ways you can do that. You now have the z-score. So we will say this, normal CDF, we want a score of 1.96 or greater. So to represent the greater, we put 1,000,000 in there. And because we're using a z-score, it's mean of 0, standard deviation of 1 times 100. So if we do that, we get 2.5%. There's another way you could have done this, okay? You could have done normal CDF, and instead of 1.96, you could have used her score, right? So 87%, you can leave it as 87, comma 1,000,000, but instead of 0 and 1, you would have had to use the class average, which is 76, and a standard deviation of 5.6. Let's see if we get the same answer. I hope so. Sometimes it's a little bit off, but we are not going to worry about that. So 87, 76. No, sorry. 1 million, 76, 5.6 times 100, not 200, 2.47. See what I mean? It's a little bit off, but I would not take any marks off because both of them are consistent. So it's either or. You want to work with her z-score, or do you want to work with her actual score? It all just depends on what you type in afterwards, right? And I think some of you are probably wondering, why didn't you convert the percentages to decimal? It's because if everything is as a percent in here, you can leave it. Inverse norm, on the other hand, that percentage to the left always needs to be converted to a decimal, okay? Her classmate Bob had a z-score of 1.26. Calculate his exam mark. They want, like, we're supposed to find the exact mark. Okay, so what we're going to do here is use that formula. X is equal to, let me think. I think it's z times standard deviation plus the mean. I'm pretty sure that's what it is. Okay, Arlene is nodding, so I'm good. Z is 1.26. Standard deviation is what in this case? Wait a minute. I'm going to be in trouble here. 1 and 0, right? That's not going to help me. Standard deviation, because the z-score tells me how many standard deviation you are. Processing, hold on. Yes, okay, got it. 1.26, so you take the z-score, and this will be the standard deviation of the class and the mean of the class. So don't go with the 0-1 narrative that we've been using here, okay? So in this case, it's 5.6% plus the average, which is 76%, okay? And if you type this all in, you get 83.06%. And we'll leave it like that as 2 decimals, even though I on your report card would round that to 83, right? What percent of class did worse than Bob? You have a choice. You can use his actual mark, or we can use the z-score. So I'm going to use the z-score. Normal CDF, worse than Bob. So we want everything to the left of Bob, right? That did lower. Right? So if this is his z-score, we want everything to the left, because to the left means they did worse. And so in this case, where is Bob here? 89.62% of classmates. I don't have a question like that here, but what if we dealt with a class of 35 students, and I asked you how many students scored less? You would actually just use that, you keep that as a decimal, 0.8962, and you multiply it by 35 students in this case. So then you round, right? Approximately 31 students scored less. So right now we're just dealing with percentages, but I believe that quiz that I'm going to give you will also ask you for the number of items or people or whatever in this case. Who did better on the exam, Susie or Bob? You can't just say Susie, you have to say why, right? So the reason is that if you compare the z-scores, okay, Susie has a larger z-score, right? So Susie, comma, because her z-score is greater. The greater your z-score, the better you've performed. Okay, what's the minimum mark? Something happened there with it. It's a typo. What's the minimum mark one would have to get in order to be considered in the top 10% of the class? So they're asking you the actual mark. So for example, right, if this is your normal curve, if you are here, right, if we find that score, then you would be in the top 10, meaning that 90% would be below you, right? So we have to use inverse norm, and we write down the whatever is to the left of the value we're interested in. The average is 76, and the standard deviation is 5.6. Okay, let's go ahead and find that out, and that is a score of 83.13% would get you that. Okay. This is where I don't want you to worry about it. So we're going to scratch 25 to 28. Don't worry about it. 25 to 28, scratch it. 29, true or false? When conducting a survey, also scratch, sorry. State the mean and standard deviation for a z-score. That is pretty easy. Mean of 0, standard deviation of 1. Okay. One thing you still have to remember is that you need to be able to graph, right? Don't forget about that. We didn't do much of that today. Any of that, I should say. So keep that in mind, right? So when you're doing a test checklist, right? Remember that you need to be able to make a line plot, a frequency, a table, frequency, polygon, and a histogram. Okay, you need to be able to do all of that. So these are graphs, right? You need to be able to know how to draw a normal distribution with percentages, right? The associated, right, percentages that go with it. Standard, normal distribution. Look at your notes. It's really a bell curve that has z-scores underneath, and that tells you how many standard deviations away from the mean you are, to the left or to the right. You got to be able to use normal CDF and inverse norm. Calculate z-score and actual score. There's those formulas, right? You need formulas for those two. Determine mean and standard deviation without the TI-84. That's how I actually labeled. If you go in your notes, we talked about that. With the average, you always divide by 2. With the standard deviation, you need to figure out how many gaps there are between the two values that I gave you. You also need to be able to answer this question. Is data normally distributed? And we will say there's 2 ways of doing that. By looking at the graph, of course, but you make a frequency line and then check if it's following this rule. Go ahead. And I'm going to go back up here a little bit, right there. And just remember, I guess it goes without saying, one variable stats, right? To find the mean, median, mode, and the range. We did that at the very beginning, right? I'll put a dot right next to it there, right? And I'll also say frequency tables, find midpoint, right? And then it's one variable stat, L1, comma L2. Okay. Is data normally distributed? Make sure you have those steps that I showed you in there. And I will do one more here. I will actually do one of those today. And then materials, right? Review materials, right? Test, review, AC. There's an old quiz. And on page 18 to 19 in the worksheet, right? Workbook. For the quiz, there'll be a video posted. The test review AC, we just went over it. And page 18 to 19, I will also be posting that. Okay, so grab your workbooks, go to page 17. Let's type that in real quick. Those values you see there. And that'll be it. That'll be my grand finale of this wonderful unit we call statistics. Not 17. Yeah. Page 17. So let's go ahead and type that in. You beat me to it. What I will do is I will attempt to create a frequency line with this and determine whether or not this is normally distributed. So according to this is 30. 3 times 8 is 24. And 6 is 30. Okay, we're good. At least I have 30 values in here. Just going to check that I didn't miss a digit. If you see a single digit, you know you did one wrong, right? So that's what I'm checking for. Let's go ahead and find the mean and standard deviation because that's what you need anyways. And let's make sure we all get the same. .96. So I will label this page 12. No, 17, sorry. I'm still needing to find the key for page 12. Page 17. So what you need to do now is, by the way, I need a couple of nods. Is that what we're getting? Okay, good. Let's make our line real quick. This shouldn't take you that long, right? But you need space. You need space for that. So mean, and then 1, 2, 3, 1, 2, 3, and yeah, if you can have them wider, even better. Okay, so I will put down 71.23 and just add a standard deviation every time I jump. And I will actually go through the motions here with you because I don't have the key. So that's 75, 19, 79, 15, 83, 11. And it's now we're going to go backwards. 67, 27. 63, 31. 59, 35. And there's our frequency line. If you like, you can break this off just to make sure you're not mixing up columns, right? So we're basically seeing, because we're using our standard deviation as the width, right? I used to make students make a frequency table, but it takes too long because if you have to do that and graph, it just takes forever. And so now we need to sort our list. So we're going to go stat, edit. No, not stat, edit. Stat, sort A, call it, tell it to sort L1. It's so much easier. And then I go through my list. Okay. Are we good with those values? I would like some of you to at least check. Don't trust me blindly. You know better than that. So 65, 65, 66, another 66, 67. We're still in this area. Another 67, 68. Now I'm jumping, right? So 68. How many 69s? 1, 2, 3, 3. So 1, 2, 3. And there's a 70. Another 70. Another 70. 71. I'm still here. 71. Another 71. 72. Now I'm jumping. 73. 73. 73. 73. 74. Another 75. I'm still there. 76. Now I'm jumping. 78. 79. 80. I'm jumping. And that's it. Don't ask me why I went a little higher here. As long as you get the numbers in the right slots, you're good, right? And so this is that's when you check, right? Plus or minus 1 standard deviation, right? We have, let's write down, we have 11 here and we have 9 here. So that would be 11 plus 9 over 24. So it'll be 20 over 24. That's 83.33%. Plus or minus 2 standard deviations. We got to go all the way back here, which is 6 in there, and there are 3 there. So it's basically everything except for the 1 here. But if I go 2 standard deviations from here all the way to there, I'm including every value except for the 1. This is probably a fail already, right? 95.83%. Plus or minus 3, that's usually 100 anyway, so it's not like. So we would say check, check, but it fails that first category, okay? It fails the first one. So data is not normally distributed, comma, since it does not follow 68, 95, 99.7 rule. That rule is called the empirical rule as well sometimes, but we're just going to stick with one name, right? It's so easy to remember even the values if we keep on mentioning that rule. And rule of thumb, plus or minus 5% is okay. Okay, so note plus or minus 5% per category is okay. Right? So if you get a 72%, for example, that's 5 over 68. Sorry, 73. That's 5 over 68. You're fine. If you get 5 less than 68, right, that'd be 63. You'd be fine. But if you're more than that, we're just gonna say it doesn't follow. You can't make that prediction, right? And if you graph it, when you graph it, you want to look at the bell shape. Basically, that's what it comes down to. Okay. We could have found the mean, median, and the mode, but we didn't. So I will tell you this on the, when you review, I haven't updated it because I started doing that recently. You know, when it says a frequency tally table or anything like that, just always replace that with frequency line. Okay, you will see my key goes through the whole thing of graphing it, but I don't want you to do that. Okay, I will ask you to graph it, but then it's going to be focused on the graph. Okay, so you don't have to worry about that too much. That's it.